So in this exercise, we have to use a PLA, that is a programmable logic array, to implement several functions. The PLA has several characteristics that are that we have 4 product terms. It means that we can build a maximum of 4 product terms. So we have here 4 AND gates to build the product terms. We have 3 sum terms. Remember that the sum terms were these OR gates in which we select the product term that we have that we want to sum in order to implement our functions. The PLA have 4 inputs available. So we are going to see how our functions are. We have 3 functions given in its disjunctive canonical form, and the functions are 4 variable functions. So we have 4 inputs. Good. So far it's good. So we are going to consider that, sorry, I'm going to change the pen. Our functions are going to be based on these variables, from the most significant to the least significant bit. So for inputs, we are going to set the input of the PLA. Good. Next step is to build the Karnaugh map of the function, something that we are really used to do. So we have 3 Karnaugh maps of 4 variables. Really easy for us. So we draw in the Karnaugh map the ones and the don't care condition of every function. So this is function 1, function 2, and function 3. In function 1 we have the 4, the 6, the 7, and the 14, and we have a don't care in the 13. In function 2 we have the 3, the 6, the 7, and the 11, and a don't care condition in the 2 and the 15. And finally, in F3 we have min terms in the 6, 7, 11, and 15, and don't care in the 3 and the 14. So let's obtain the prime implicants. For example, here we have this one, this one, and this one, and all of them are essential prime implicants, so I have to use all of them. And I'm going to make it quick because you know how to do it. So the min terms are these ones, In the case of F2, we have two prime implicants using the don't cares that are the following, this and this. So F2, sorry, X2 is the sum of both essential prime implicants, because both of them are essential. I don't know what happens with the sum, sorry. So we have these product terms. They are product terms and not min terms because not all the variables are included in the product term. So if when speaking I make some mistake, just take that into account. We have essential prime implicants that are product term, not min terms. And finally, in F3 we can form again these two prime implicants. And we are going to have this CD plus BC. So these are the minimal expressions of the three functions, and we are going to see how many product terms we have in this expression. We have 1, 2, 3, 4, 5, this is repeated, and 6. So we have 6 product terms, and we can implement with this PLA only 4. So we cannot implement the functions this way. Remember that I told you in class that when using PLAs or PALs, not always the minimal expression were the more appropriate. Our goal in this kind of devices, in this kind of combinational circuits, can be find product terms that can be shared between different functions, even if they are larger than others. So, for example, what happens if we cover these ones just taking these 2 cells instead of the 4 cells? If we cover function 2 and 3 using this implicant, even if it's not a prime implicant, we are not obliged to use the X. They don't care, we can use them or not. So now I'm going to ignore this X and I'm going to form this implicant. I'm covering the function as well, but what happens? F2 and F3 are sharing the same implicant. So now F2 are going to be like this: A negated BC, that is this new implicant, plus the previous one, that was CD. And F3 is going to be this new implicant, that is this, plus the previous one, that is CD. And how many product terms do we have now, considering this new version of F1, F2, and 3? We have 1, 2, 3. This is repeated, it's the same as 3, and this is repeated, so this is 4. So now we have 4 product terms, and we can use the PLA to build these functions. So in the first column we are going to construct the first product term, that is A negated B denegated, A negated B denegated. This is going to be F1. So f1 is this product term. In the second column, I'm going to build the second product term, that is BCD, being the D negated. So BC D negated, that is the second product term of f1. So it's going to be here. So in the third product term, we are going to build this product term, A negated BC, A negated BC, that is the third and last product term of f1. So f1 is the sum of three product terms. So now we are going to build f2 and f3. The first product term of f2 is already implemented in the PLA. We are going to implement the second, CD. CD is just marking these cells, CD. So f2 is A negated BC plus CD, and f3 is exactly the same, A negated BC plus CD. So in this way we have implemented three different functions using this PLA with these constraints. So when we have PLAs and PALs, our goal, I insist, is going to be to find product terms that we can share between the different functions instead of having the minimal representation of each function separately. So we have finished the exercise.